Now that we understand the dead man switch, its different stages of operation and how to work with it, we'll execute movements now on the robot. Since I'm working in a virtual environment, I don't have the same resources as I would in a physical robot. And in my case, I need to give consent here. And you'll notice that every time the controller has consent to move, we have those indicators here, like this arrow and all of these indicators here turned green. So note I can only move the robot if these are green, okay? As I mentioned earlier, each key here represents one axis or plane of movement. This is because I am configured here to move as the TCP, the two center points. So I have a TCP here. So it will move axis along axis X, Y, Z, and so on. Consent is enabled, so I can move everything. And if I click here, I can change the movement from the TCP to a joint movement, so where I can move each individual axis or joints of my robot, A1, A2, and to A6, all the 6 axes of the robot. Here, working on T1 mode, I have options to adjust the movement speed of the robot. Okay, I can adjust both the automatic speed here using these keys. So if I click minus here, you see that the automatic speed decreases. Okay, so this is the automatic speed. I can increase or decrease using these keys here. And down here, I have the manual operation speed, which is the speed that the robot will move when in out of manual mode. And you can see up here, if I click here, I have this window here to configure with a sliding bar, or I have these minus and plus buttons that move that changes more quicker the value here. And here down here I have the manual speed, so I can configure them independently. Okay, I can also adjust using the slider or directly here using the key and scene up there in the toolbar. Since I don't have the physical robot, we cannot see it moving properly. I am going to do the following. I'm going to enter the menu, so I can both click here on the manipulator icon, or I can also click this button here in the TP. And now I have in the menu, I can go to show or view actual position. And here we will have the current position of each individual axis or joint of the robot. So I can see, I like to compare this to the movement of the ABB robot, where you can see each axis moving individually. Here we have the option motor. If I click on motor, I got a better view of each axis. So I have these two display options here. Here I'm visualizing each axis from 1 to 6 and the robot's current position in them. For example, if I move axis 1, you see the values changing here. So if I move here, you can see the axis 1 is changing the degrees, and you notice it moves faster. And if I decrease it and set it to 1% here, so let's place 100% here. This way you can control the speed precisely, so you can adjust the speed and move at the speed you need. If I reduce it to, let's say, 1%, you see that it moves really slow with a lot of precision. And this is useful when you're programming and positioning the robot to start a program. Notice that the manual speed I set here isn't the speed the robot will execute in manual mode. It also serves as an increment function. This function is useful when working in areas with collision risks. So actually the manual speed, the increment function, allows us to make precise movements in areas where the robot is operating or near collision risks. By reducing the speed, we can achieve slower and more controlled movements by doing this and avoid collisions if I'm working in an open area, for example. I can simply set it to 100% then, and and if there's no risk of collision, I can use the full potential of the robot. Another robot that uses this concept is the Motoman. The Motoman also has this feature where you can increase the speed for faster manual movements. So I'm currently moving axis 1, and now I'll move axis 2 down here in this other key. Okay, axis 2. So I can move each axis independently from each other, basically. Okay, and you can see the values changing there in the current position indicator of the robot. See, axis 4 is moving. In the KUKA system, you might notice some lag here because this virtual machine only has two gigabytes of RAM, so it may be freezing at some point, which is quite a limited RAM memory for running a Windows-based system. As a result, it sometimes freezes or takes some moments to respond. For example, when I open the current position menu, it took a while. However, when working with the Teach panel itself, it's much faster. So I switched to current position, and you saw it took a moment to open, but when using the real thing, it's much more responsible. So it doesn't behave like that, of course. That's basically it for movement control. These are the key features for the KUKA robots you encounter when operating the robot. And we've covered the basics of it, I think. So in the next lesson, we will explore the difference of those movement functions here. We'll look at the word frame, we will look at the base frame, the to frame, and the reverse function, which is a useful feature available in newer versions. Not all controllers have this reverse function, so keep that in mind. Alright everyone, see you in the next lesson.